Hello, everyone, and welcome to chapter 6 and section 6.1, where we're going to go through factoring. And in particular, we're going to talk about greatest common factor and factoring by grouping. Okay, so just remember, what is a factor anyway? So if you have a number that is a product of two other numbers, those two numbers are considered factors. So this is a factor, 8 is a factor, 7 is a factor. When you think of like the number 8, 2 and 4 are possible factors, so are 1 and 8. Okay, so it's just the parts that when multiplied together become a number, okay, and that number is considered the product. Now that also extends to variable expressions. So see here you have the product 2x squared plus 6x. If you think of it that way, it can be split into two factors, 2x and then x plus 3. So it's the same thing. Now, let's introduce the greatest common factor. So basically, it's if you have a polynomial, and you have all the polynomial has different terms, the factor that can be divided into every single term that's the greatest is literally the greatest common factor. So the name is not creative at all. Okay, so how can we do that? We can factor into primes and then write it all in expanded form and then connect them. So let's say we have here, we want the factors of 21 x cubed, 9x squared, and then 15x. Okay, so 21 and x cubed. So you have 21 times x cubed. 21 is 3 and 7. X cubed is just x times x, right? 9x squared is, so you have 9 times x squared. 9 is 3 and 3. X squared is x times x. And then 15x, so same kind of things, 15 times x. And you can split this up into 3 and 5. Okay, so here are all the, factors of each one, the prime factors. This is kind of like you could say prime factorization. So which ones do they have in common? That's your GCF is going to consist of all of them. So what's in common in all three? You have a 3 here. So this one, and this one, they share that in common. So I'm going to write that down here. Any other numerical part? No. I have an X here, an X, and an X. And that's everything that they have in common. So your greatest common factor for all these three is 3x. Okay, so eventually you don't have to write this chart every single time. You don't have to make the little trees and stuff unless you want to, because eventually you can figure out this is what divides into all three. It's the greatest thing. And remember distributive property. So if you have a number times a binomial or trinomial, but basically a sum of other terms, you can distribute that when you're multiplying, okay? It also works in reverse order. So if you have a sum of two numbers where you have the same factor, you can, factor it out, okay? And you rewrite it using this distributive property in reverse. Okay, so we use factor as both a noun and a verb. So we could say that 7 is a factor of 14. So 7 times 2, right? So 7 is a factor. And then if you have 3a plus 3, we want to factor it out. We say, oh, what's in common is a 3 plus 1. So this is factoring, so we use them interchangeably. So just be mindful, Okay, so let's go ahead and do some factoring. So basically we want, what is the number that divides into all three of these? Okay, so you can go ahead and do your trees, but I can tell that 4, my GCF is going to be 4m, and that's it, 4m. So I'm going to factor this out. So I'm going to write 4m, and then inside the parentheses is going to be 4m times what gives me 8m cubed. So that's 2m squared. Minus 4 times what gives me 12, 3. M times what will give me m squared. And then there's an n, so I have to consider that. And then plus, so another way to think of it is 4mn squared. You're basically dividing, right. You're dividing it, but it's kind of helpful to ask yourself what times the GCF will give me this product, So here we have a 5 in common. My GCF here is going to be 5 and then x squared, because this is the lowest amount of variables is your GCF, right? So the lowest power. So let's write that out here. And what's left in the parentheses is x minus 5. Okay, so that's it. So I factored it. We know that it's completely factored because we can't factor this any further. We can't pull this out anymore and rewrite it. Okay, so we just leave it like that. Okay, so let's go ahead and do another one. What is the GCF of 8x cubed y, 10x squared y squared, and 12xy? So what number divides into all three? Well, we know 2 does, right? And nothing else, because 5 doesn't divide into anything else. So then we have, what is the least amount of x's? Here we have 3, we have 2, we have 1. So 1x can come out. And then y's, we also have y. Okay, so let's go ahead and what times 2xy will give me 8xy, x cubed y. So I know that I need a 4, and then I need 2 x's, x squared, and then that's it, because I have a y right here. Then minus 5xy plus 6y squared, and that's it. We can't factor anything out from here. So then here we have negative 4a cubed, 36a squared, and negative 8a. So I can factor out a negative 4a. That could be my GCF here, because that's what divides all three. And also, since there's a leading negative, I'm just going to go ahead and take it out. So I'm going to write negative 4a. And then I'm going to see what else do I multiply by each term to get this inner, right? So I have here a squared, okay? And then it's going to be a minus because I'm factoring out a negative. So this is going to be 9a. And then here I have a plus because it's negative, so then 2. And you can check yourself. Like you can check yourself by distributing and then saying, okay, what is this? This is negative 8a cubed plus 36a squared minus 8a. So it is what we started out with. It should be, okay? So now here, so that's it. Let's do another one. Here, what's in common actually is interesting is the binomial. The binomial is in common. So we can factor that out. And what's left? We have 3y and then minus 4, and that's it. And that's it for this one, because the GCF in this case was y plus 7. Okay. So this leads us to this method called factoring by grouping. So when you have 4 terms, sometimes more, we take the terms and we group them 2 by 2, and then we factor out the GCF of each one. And then when you have another GCF, we take that out. So I'll show you what I mean. So let's say here, factoring by grouping, I'm going to group these 2 together and these 2 together. So for the first, so basically it's like I'm going to ignore, I'm not going to look at, I'm just going to look at these 2, okay? So out of these 2, my GCF is y, and I'm left with x plus 3. That's just this part. So then I bring down this plus. Then now I look only at 2x plus 6, okay? So now I'm factoring this. So 2 comes out, and I'm left with x plus 3. Okay, so now notice I have a common factor of x plus 3. So I'm going to pull that out, x plus 3. And what am I left with? I'm left with y plus 2. And that's it. And that's factoring by grouping, okay? Because you group them separately, take out the GCF from each one, and then see if there's a common factor, and then you check, you know, you can multiply this out and you'll get the same thing. Okay, so let's do a couple more. So factor by grouping. So I have x squared plus 3x minus 2x minus 6. Out of the first 2, I can factor out an x, leaving me with x plus 3. Out of the second 2, I can factor out a negative 2, which leaves me with x plus 3 again. So now that these are the same, I can say, okay, that's x plus 3. What's left on the inside is x minus 2. Okay, so that's that one. Let's go ahead and do the next one. We have here 6x squared minus 3x minus 4x plus 2. So factoring these 2 and these 2 together, The first two, I can pull out a 3x. That leaves me with 2x minus 1. Now the second two, I can see there's a negative, so I can take out a negative 2. Okay, and then we just have to be careful with our signs. So negative 2 times what gives me minus 4x? That's 2x. Negative 2 times what will give me a positive 2? And that's times negative 1. So see, this ends up being the same thing. If you're trying to factor by grouping and you don't have the same term in the parentheses, something went wrong. It's a good way to like see, oh, okay, am I going in the right direction? So there you go. So that's it. And that's it for this section. Good luck, happy studying, and I will see you on the next video.